So in this video, I'm going to talk about time value of money. So we're going to do a whole bunch of different calculations with time value of money. So problem number one says, suppose that you have $2,000 and you plan to purchase a 3-year CD that pays 4% interest compounded annually. How much will you have when the CD matures? So we're going to set all of our time value of money problems up the same in Excel. So PV, which stands for present value, FV, which stands for future value, PMT, which stands for payment. We're going to have K, which stands for rate, and N, which stands for number of periods. So in this problem, they gave us some information. We know that you have $2,000, so that's today's dollars. So that's present value. I'm going to format this so we can see dollars. And we know that it is paying 4%, which is our interest rate, or K, annually, and that it's going to last 3 years. So what we're going to solve for is how much will we have when the CD matures, which is future value. I'm going to highlight what we're solving for in yellow so you can find the formula. So I'm going to hit fx, which is the function, and I'm going to type in, you can go up here, I've used these formulas recently, and I'm going to type fv, which is future value, and hit go. All right, fv came up, it's highlighted, I'm going to click OK, and now it's going to tell me, what's my rate? My rate is K, my number of periods is N, and I don't have a payment, so I leave that blank, and I put a negative sign because it's a negative here to solve for Excel, otherwise you'll end up with a negative number. I put a negative, and then I touch present value. So in this problem, if we have a $2,000 CD for 3 years that's paying 4% annually, we would end up with $2,249.73 at the end of 3 years. So that's our first problem. That was solving for future value. Our second problem, you want to go to grad school 3 years from now, and you can save $5,000 per year beginning immediately. You plan to deposit the funds in a mutual fund, which you expect to return 9% a year. Under these conditions, how much will you have just after you make the third deposit 3 years from now? Okay, so an annuity is an equal series of payments. So this is an annuity problem. So present value, future value, PMT for payment, K for rate, and N for number of periods. So in this problem, we don't just have a present value, we're going to make $5,000 payments per year. So we're going to put the $5,000 in the payment form next to payment. We know our interest rate, we're expecting a 9% return, which is rate, and it's going to be for 3 years. So we're solving for, and now there's 2 different types of annuities. Sorry, click this on Excel. There's 2 different types of annuities. There's an ordinary annuity and an annuity due. So one is that it starts earning interest immediately. In this problem, it says you can begin immediately. So instead of depositing the $5,000 at the end of the first year, we deposit at the beginning. So that gives us more time to earn interest. So there's a way you represent this in Excel. So we're solving for future value again, but this is with a payment instead of just one lump sum. I'm going to hit future value. Future value is already up here, so I'm going to select that one. And I know my rate is 9%. I just touched the cell. My number of periods is 3. And now I'm going to put a payment instead of a present value, and I just put the negative sign and touch the payment of $5,000. Now, if you're investing the money immediately at the beginning of the period, see, this is type. If it's representing a timing of a payment, the payment at the beginning is a 1, the payment at the end of the period is a 0, or just leave it blank. So in order to say we're investing it immediately, we're going to put a 1 under type. So if we had $5,000 per year invested immediately, we would have $17,865.65 to go to grad school. All right, problem number 3. Problem number 3 says, suppose you inherited $200,000 and invested it at 6% per year. How much could you withdraw at the end of each of the next 15 years? So now we're going to take out money. All right, so present value, future value, PMT, KN. All right, so we know we have $200,000 that we inherited. I hope I inherit $200,000, right? be a good thing. So we have $200,000 that we inherited. We know that the interest rate is 6%, and we are talking about 15-year period. We want to know how much can we take out each year. And I'm solving for payment this time. So now I'm solving for payment. So I'm going to go into the payment. I'm going to go to the FX right next to it. And now I'm going to type in PMT. Go. And now we're going to select this function in Excel. Now it's telling us take the rate. Sorry, I touched the wrong cell. Rate, our interest rate is 6%. Our number of periods is 15. And our present value, put the negative sign, is 200,000. So we could withdraw $20,592.55 at the end of each year if we invested the 200,000, and then we get to zero. So over 15 years. So that's solving for payment. Now let's talk about what is the present value of 2,000 discounted back for 3 years if the appropriate interest rate is 8% compounded monthly. All right, now we have to match. We have to remember to match monthly to a monthly interest rate, right? So present value, future value, PMT, K, and N. So we want to know the present value. So now we're solving for present value. We know that we want to discount back, which is our future value, $2,000, right? Format this. And we know that the interest rate is 8%, but that's annual, equals 8%, and we need to divide this by 12 because it's compounded monthly. If it was compounded quarterly, it'd be divided by 4. If it's compounded semi-annually, like bonds, it'd be 2, right? So that's our monthly interest rate. And then we need to match, sorry, I put that in the wrong spot. So K is our rate. So it equals 8% divided by 12. And our number of years is 3 years, but we want monthly. So 3 years is 36 months. We multiply by 12. So you take the number of periods, multiply by 12, the interest rate divide by 12 to get a monthly interest rate out of the annual. And now we're going to solve for present value. So I'm going to type PV into the formula up here to search for. I'm going to select the PV, and now my interest rate is K, my number of periods is N, and my future value is 2,000. So the present value of 2,000 discounted back, with a monthly compounding is actually worth in today's dollars $1,574.51. The good thing about Excel as well, this is what I like to do in Excel, is that let's just say, I'm like, well, what if the interest rate was only 5% in discounting? I could just go in and change the 5% formula. Well, then it'd be worth $1,721. So I'm going to fix this back, but that's why I like to use Excel. I can say, well, what if... All right, so on to problem 5. Suppose you borrow $25,000 at a rate of 8%, and you must repay it in 4 equal installments at the end of each of the next 4 years. How large would your payments be? So, setting up the problem the same. PV, FE, PMT, K, N. All right, we borrowed $25,000, so that's present value, what we borrowed. We have an interest rate of 8%, but we want to make 4 payments, so we got to divide this by 4. Oh, actually, so 4 equal installments at the end of each of the next 4 years. So actually, it's an annual interest rate, 4 equal installments. So 8% is our interest rate, 4 is our number of periods, and we are solving for payment. FX. And I can just go to the list if I've already used it. Payment, click OK. So rate, then we have number of periods, and then we have negative sign present value. So to pay off $25,000 at an 8% interest rate, we'd need to make payments at the end of each year of $7,548.02. All right. Number 6. All right. Let me change this handout. Number 6. So if you're in my class, you're following along, you can download the setup, the handout set up in Excel, and all the problems are already in Excel. So you can follow along with this video. All right, so your sister turned 30 today. She's planning to save $3,000 per year for retirement, with the first deposit being made 1 year from today. She will invest it in a mutual fund, which she expects to provide 10% return per year. She plans to retire 35 years from today when she turns 65. She expects to live another 30 years in retirement till 95. Under these assumptions, how much can she spend each year after she retires? Her first withdrawal will be made at the end of the year. All these end of years are telling me that these are ordinary annuities and I don't need to use the 1 in Excel. So this is a 2-step problem. Step 1, calculate savings at retirement age. All right. So then we're going to do PV, FV, PMT, K, and N. All right. So it says she's going to save $3,000 per year, $3,000 per year. Ordinary annuity, because she's doing it at the end of the year. She's investing in a mutual fund that's going to return 10% per year. And she plans to retire 35 years from today. So we want to solve for future value for this first step. Future value. So I'm selecting it off my list over here instead of searching it. So my rate is 10%. My number of periods is 35 years. And my payment is $3,000 per year. Okay. So when she retires, if she saves $3,000 per year from 30 until 65, she will have $813.73.11. Step 2, calculate what she can withdraw. All right. All right, so we're going to calculate what she can withdraw. So we're going to set up the second time value of money problem, PV, FV, PMT, K, and N. So our present value technically equals the number that we solved for up here. Oh, I'm going to put that in present value. Right. So our present value equals the number we solved for up there. We're going to use the same interest rate. Now, in financial planning, we wouldn't use the same interest rate because you're not going to invest as risky. And it's going to be over 30 years now until she's 95. And now we're solving for payment. So I'm going to solve for payment. Our interest rate is 10%. Our number of periods is 30. And our present value is $813.73.11. So she can withdraw $86,250 if she leaves the balance invested, earning 10%. Every year at the end of the year, she could withdraw $86,250.18. And that is an overview of time value of money calculations in Excel.